From Toro Cloud, this is the Coding Over Cocktails podcast, a free pool of thoughts and ideas from IT experts, thought leaders, and authors, sharing their insights and advice for individuals architecting solutions for the ever-changing landscape of enterprise tech, digital transformation, and more.
Welcome to episode 80 of Coding Over Cocktails. My name is David Brown. Our guest for today is a consultant, author, and instructor. He is the founder of microapis.io and the author of Microservice APIs, which is currently available under Manning's Early Access Program. He is recognized as a thought leader in the fields of cloud computing, DevOps, and automation, and he speaks regularly at international conferences and frequently organizes public workshops and seminars. Joining us for a round of cocktails today is José Haro Peralta. Hello, José. How are you doing?
Hi, David. Thank you for having me. I'm very excited.
Good. Well, it's a pleasure to have you. Congratulations on the book. It's on the Early Access Program. So when does that mean it will be published as a completed product?
We're expecting the book to launch in January next year, January 2023.
Yeah, I mean, it's already pretty comprehensive, so it must be pretty close. So let's get started. We'll dive into some of the topics of the book. You mentioned in the introduction of your book that what inspired you to write it was years of experimentation, and often through frustration of building microservices platforms and driving integrations through web APIs. So run me through what these frustrations were and share some of the challenges you faced.
Sure. So I have a lot of stories about this, but I think the most recurring theme around these stories is, working with a team. We're trying to build an API integration, and obviously we're trying to build this API, and the client development team and the backend development team, we sit together, we discuss the requirements of the API, we agree on something, then we part ways, we build a client and the server, we try to get them talking to each other, and it's like they are talking different languages. And so what we need is a number of processes and tools that help us deliver these API integrations more reliably. And what I try to do in the book is to explain some of these processes and tooling that would help people avoid these situations.
Okay, well, let's dive into some of those processes and tooling. So you talk about documentation-driven development. Let's just get started with that. What is documentation-driven development?
Sure. So, when you talk to API practitioners, we've had this idea of that to build an API, the right approach is to do API first. Now, API first is a little bit ambiguous, more recently we realized we have to be a little bit more precise what we mean by that. And so we come up with the concept of design first. And that's a great concept. It means before we build the API, we should design it. Because at the end of the day, when we're building an API, we're building it for our consumers. It's like similar to building a UI. We are building a UI for users to use it. We're building an API for a client to consume it. So ideally, we design the API to meet the requirements of this client. And there is a design process to get that done. But when it comes to this reliability of the integration, what I want to make sure is that we have something more specific than that, something we can use to validate our implementation. And that's what would be the documentation or the API specification. So I want to be more specific that what we need is this API specification in place.
Okay. So the documentation project is part of the design process. It's still encompassed in API first development. It's the initial part of that process, is sitting down, designing it, documenting, getting everyone on board before you start writing any code. And is there that collaboration process between stakeholders and developers, and who's in the room?
Everybody, it's like when you're building a UI, really. When you're building this UI, because it's going to have implications for the backend. It's obviously the front end application and for the stakeholders, designers, product manager. So everybody who has a stake in the API should be in the room, because we are trying to serve the needs of the client, of the stakeholders who are going to use this client, and it's going to have implications for the backend as well. So it's going to have to be a conversation between everybody who has a stake in the API.
And how comprehensive does the documentation become before you start mocking the services of the API?
What I would say is the best way to start is small. So like the approach that I always try to evangelize is to have ideally a very comprehensive API design, very detailed, and then you go to build it. Obviously, this is not realistic in a practical scenario, because the way you're going to discover what the API needs to look like is when you start tinkering with it. So the best way to get started is to have a conversation about what the API should look like, then do some experimentation, build some in the backend, put together some endpoints, some payloads, see what it implies for the process of fetching data from your database, transforming that data, computing certain properties. Do the same in the front end, or your client could be a CLI, could be an IoT device, whatever is consuming that API. See what you need to get from the API at every stage of your communication, and see if this makes sense also for the stakeholders. So this is a dynamic process at the beginning, but what you want to make sure you have at some point is this consolidated API specification and then building against that.
Mm-hmm. Okay, now in the start of the book, you launch into REST APIs and GraphQL APIs. Run us through the use case of each, and are they the only options for microservice APIs?
So to answer the last question first, absolutely not the only option. There's also a popular choice is also gRPC, and these are all synchronous APIs. You can also have asynchronous APIs as well. So like if you have a queue or a stream between your services, in terms of comparing REST with GraphQL, what I would say the best use cases of each is REST when it's straightforward to fetch a resource representation from the server, and it kind of matches exactly what you need in your client. And GraphQL when you need flexibility querying those resources from the server, because that's the whole point of GraphQL, right? So you have these very complex and very very big representations of resources in your server. You don't need all of those properties in your client, so you need to be very selective with the information you get so that you can get everything you need. And that's a good case for GraphQL.
And I'm guessing there, in a microservices integration, a larger one, you could have use cases where you're using both. Would that be reasonable?
Exactly. Yeah. Sorry. Exactly. So a very popular pattern these days is to use GraphQL as a kind of front end for REST APIs. So as a kind of gateway. So to simplify things for your consuming side, so for your API clients, very popular pattern is to put a GraphQL interface between the client and your services. And this GraphQL API knows how to fetch data from different services. And the client only needs to know how to query data using GQL, the GraphQL query language.
Okay. Why is that becoming popular?
I guess it's because it offers a simplified and unified interface for the client. The client doesn't need to know about different endpoints for different services. Everything is just one single endpoint for querying data, and it's the same query language for all services. You don't need to worry about different endpoints and domains and so on. All you have is queries and mutations, and these queries and mutations, because they are decoupled from the services, the same query maybe can combine queries from 3 different services, perhaps. And also this middle layer can maybe leverage caching and some things that might not be so easy to orchestrate together with the separate services.
Makes a lot of sense. In your book, you discuss the adaptation, I should say, of a 3-tier architecture to structure microservices into modular layers. Can you run us through this concept of layers in these 3 tiers?
Sure. So it's one of the earliest architectural concepts, I guess, when we get familiar with, right? When we are building web services. So the idea of 3-tier architecture or multi-tier architecture, as we also know it, the idea is we structure the application in 3 or more layers. The idea is that every part of the application goes into its own space. So typically we will have a presentation layer, a business layer, and a data access layer, or presentation tier, business tier, and data tier. So the idea is these different domains of the application live in different spaces, and visually or architecturally, the idea of three-tier architecture helps us to decide where to put it's part of the application. And the idea obviously is we would have each layer completely coupled as well.
Now, this leads us towards something else you talk about, which is a hexagon architecture. So it sounds a lot more complex. Now the idea is loosely coupled services, but how is it different from the three-tier architecture?
Sure. In multi-tier architecture, the idea is the proposition is very simple. We structure our application into tiers. The idea of the hexagon, so hexagonal architecture built into this tradition of how we can build multi-coupled services with clearly defined boundaries and so on. So the idea is visually we think of this hexagon, and the idea is this center of the hexagon represents our business layer, and that's the part of the application we want to isolate and maintain free of dependencies from external components. Then the external components becomes the edges of the hexagon. So we know hexagonal architecture also as architecture of ports and adapters. Then the idea is these external dependencies of the app, like a database, like an API interface, a CLI interface, a cache. These external dependencies, which are not necessarily to implement the business layer, they just help us operate this business layer. So they become the adapters of the application. And then we use ports, which are technology agnostic interfaces towards these external dependencies. So the idea is our business layer, when it's talking to the database, it doesn't know it's talking to a database. It's just using something to persist data in a persistent storage. And the port takes care of translating our business commands into database-specific transactions. So the hexagonal architecture has a much more clear proposition of how we decouple the business layer from our external dependencies. That's what I love about it.
So there must be some benefits to using the hexagonal architecture. Is there benefits in terms of testing or development? Where do the benefits come in?
Exactly. So because it helps you decouple the business layer from everything else, you're able to test the business layer in isolation. So it means when you're testing your business layer, you don't need to have a database, not necessarily. And in some cases, you may want to have it. But in most cases, really, you want to test that your classes and functions are doing what they are supposed to do, regardless of whether there is a database or an interface or something like that. So you can test the business layer in isolation, and you can replace, because the port encapsulates the complexity behind the adapter, you can put behind a test adapter. That's the idea. So instead of having a real database, you have something that looks like a database, but the business layer doesn't care because the port is handling this communication with the external dependency. It also, because everything is decoupled, if it's properly done, your business layer doesn't depend on the database or the API. It means you can, if you have situations in which you have changes to the schema of your database, which are not directly relevant for the business layer, those changes are handled by your ports and adapters. The business layer is not affected. It shouldn't leak into the idea is preventing these external dependencies from leaking into the business layer. So very common situation, for example, renaming a column in your database. It's the same data, everything is the same, just change the name. If you have this typical pattern in which you're basically streamlining, you're going to break the API immediately because you changed one name in a column, a property name changes. But if you have this translation between layers, then the translation middleware handles these changes and protects and isolates your application from those changes. So in terms of development, it's a much better experience for the team, because as small changes to the external dependencies don't impact the core application.
Does it change in any way the concept of domain-driven design for microservices?
I think it goes well with it. So in terms of, we would apply domain-driven design in different levels when we're working with microservices. So we can use domain-driven design first of all to break down our, we use the concept of subdomains, right? So we may have a payment subdomain, uses subdomain, claim subdomain, and they become individual services. But then within the service, we can still leverage domain-driven design and its patterns to make our implementation better. So we will still use domain objects, domain entities, data objects, and so on to make our implementation better.
Mm-hmm. It sounds like it's a more complex scenario to develop this way. Are there use cases for the hexagonal architecture? There are use cases where it's not worth the effort? Or, when do you recommend to use it?
I would say let's maybe start with when I wouldn't use it. And I would say I wouldn't use it if the application is going to be like really simple, then perhaps I wouldn't use it. But if there is any chance that the application is going to grow complex, it really is not very difficult to lay the foundation of a good structure and good architecture for your application by, there's nothing necessarily complicated about hexagonal architecture. And although the pattern encourages you to have fully decoupled business layer from the adapters, this is something that can go also progressively. Maybe in a first iteration, you may have database logic leaking into your business layer, and that's fine at the beginning. But as you move on and the database becomes more complex and the interface becomes more complex, you want to make sure that you're fully decoupling each layer so that the evolving and development of each layer can happen more easily without interfering with each other.
And
and then that's when we introduce all the pattern.
I'm sorry, I interrupted you. That's when we introduce.
So to enforce this decoupling, there are some patterns I introduced in the book as well, like for example, repository pattern, which is very commonly used in domain-driven design as well. So to decouple the data access layer from the business layer, it's a good pattern to do that.
Okay, and I'm guessing that under this architecture, it's agnostic in terms of the style of API you're using as well, whether it's REST, GraphQL, event-driven, or anything else.
Exactly, because the basic idea is so simple. You have a core business layer and external dependencies. APIs are external dependencies because it's what allows you to expose the capabilities of your service to the world. It doesn't matter if it's a REST API. As a matter of fact, any kind of architecture would allow you to do that anyways. But it fits very nicely in a hexagonal architecture, thinking that you can have different interfaces to the service. So it can be a REST interface, it can be a GraphQL interface, it can be a CLI interface to the service. And all these interfaces sit together outside of the business layer. They are just consuming the capabilities of the business layer. And the business layer is not bound to any of them because we want to keep it isolated. So it's perfectly possible and it fits nicely with this concept.
And the concept was introduced in, as I understand it, 2005 by Alastair Cockburn. So it's basically an adaptation of that concept to microservices, right? So is it something which is just recently been adapted and is taking off, or is it just slowly evolving? What's initiated this?
I would imagine, just to clarify first of all, the hexagon architecture applies to individual services, not to the whole architecture. So when you're building an individual service is when you want to apply this architecture inside the service. And I would think that hexagonal architecture has been quite popular since the beginning, but perhaps I've seen more recently a lot of emphasis on hexagonal architecture perhaps what we are seeing is a lot of developers coming to face with the fact that growing applications, growing in complexity, need better structure, and hexagonal architecture is a good solution for that. And it's true also when you see diagrams of microservices, every service is always a hexagon. So we've come to think naturally of a service as a hexagon, and it's very embedded in our developer culture, I think now.
Interesting. Tell me, does the container orchestration engine which you're using to power your microservices, does that affect in any way the architecture or APIs you're using? So does it matter whether you're choosing Kubernetes versus Docker Swarm or a proprietary solution like AWS's Elastic Container Service, for example?
It shouldn't have any effect. So your infrastructure should be completely decoupled from the implementation of your services. There are obviously technologies that these cloud services provide that can support your implementation. So AWS API Gateway, for example, is a great support for your REST interfaces. But otherwise, I would be very, very careful not to tight couple your service implementation to infrastructure. So whether you use Kubernetes and whether it is in GCP or in Azure or in AWS, or whether it is the Elastic Container Service, or whether it is something like Heroku or Render, your implementation should run just the same, and infrastructure should help you just with things like reliability, operations, availability, redundancy, and things like that.
Yeah. Look, your book is incredibly comprehensive, covers a lot of ground. Who is the intended audience for it? Is it the stakeholders involved in the API, which in particular, like the architect or the designer? Who is it?
So during the book review, a lot of reviewers highlighted that the book is useful for a lot of stakeholders in the system, from developers to CTOs, and going through managers, business stakeholders, and VPs of engineering, and so on. And I think to an extent it's true, because by giving all these approaches and tooling, it can help business leaders to make better decisions, or technology leaders to make better decisions about the implementation strategy. But at the end of the day, what I had in mind was the developer who's working day to day with microservices and APIs. And really the kind of setting I had in mind is a lot of companies that I work with, mostly so like growing startups that suddenly they need to work with microservices and APIs, and because everything is going so fast and everything is growing so fast, there is not much time to teach how to do things and how to put in place a proper strategy, because it needs to happen very fast. So what I say is often these developers are lost and they have to figure out a lot of things by themselves. So I'm thinking of these people. How can I make their life easier in this situation, which is so common? And really what I wanted, it covers a lot of ground, but what I wanted to give is just kind of like the basic stuff you need to know in each step of building a microservices platform and the APIs. So in terms of documentation, design, implementation, authorization, and deployments, just so that you have a roadmap in your mind. Because otherwise, I know the feeling when I work with these developers is feeling so lost with so many choices out there. And in every step of the process is, how do you document it? How do you test it? How do you authorize? What about security? What is this? What is JWT? What is OAuth? What is OpenAPI? So just bringing together all these things for these people who are working on these things every day.
And because you do give some examples for developers in Python, but the concepts apply to any language or even a low-code platform.
Absolutely. So the original title of the book was Microservice APIs in Python, But during the review process, like I said, some reviewers were highlighting that the book is actually useful for more than just developers. And a lot of reviewers also highlighted that what I teach is not just for Python developers. There is a lot of content which is useful for people working with different stacks. So we decided to leave it as microservice APIs, and we just happen to have the examples in Python. But the principles and the patterns and the strategies that I teach in the book apply regardless of the stack.
I think it's a very easy read, and there's a lot of valuable information in there. Jose, congratulations on the book, and how can our listeners follow you and make sure they're up to date with the announcement of that book? What are the best social media platforms to follow you on?
The best one, I would say LinkedIn. So follow me or connecting with me on LinkedIn. I like to connect with people there, and I think every day we have some interesting conversation on LinkedIn. It's becoming really a great forum to talk about anything related to tech. And for announcements, I have a newsletter in Superstack. It's microapis.superstack. So registering with that newsletter is also a good way to stay up to date with my book, workshops that I release every so often, or new content that I'm publishing related to the book.
And your handle on LinkedIn is José-Haro-Peralta.
I think so, but I need to check. Let me... exactly, like you said, yeah. José Haro Peralta.
I've separated by hyphens. Okay. All right. Look, Jose, thank you so much for your time today. Congratulations on the book. It's a very easy to consume book. So much useful information there, introducing some really good concepts like the hexagonal architecture, which is really, really useful information. Perhaps not as widely known as some of the other concepts like REST and GraphQL. So I would highly recommend it to our listeners. Thank you for coming on our program today.
Thank you so much, David.
It's a pleasure.
Hey listeners, thank you for joining us in this round of cocktails. Please like and subscribe to check out other episodes of this podcast series. We're also available on your favorite podcast platforms, or you can simply listen in at torocloud.com, where you'll find full episode transcripts and show notes. On behalf of the team here at Toro Cloud, thank you very much for listening to us today. This has been Kevin Montalvo for Coding Over Cocktails. Cheers!